All right. Hello, everybody. Welcome to our session number 5 on pre-stress models in BrR. So before I hand it off to Pro Miles, I just wanted to share a couple things. Share my screen. So just yesterday, we updated the system file and library files. So you can find the new ones here on the SIMS resource page under library and system files. And we have a couple documents here that can kind of walk you through how to add certain parts or update those after you've already updated some. So the changes we made there are for the system files, we just added a couple more custom agency fields, two that we're going to fill in for the templates to help you guys with that, and a couple more fields that will help you guys kind of track modifications that you make over the years. So that's the system file. And then related to Prestress, in the library, we have added, if you go to I-beams, wide top flanges, we've added the bulb tees, so the E, B, C, and D. So there's shapes and everything you can find in here, as well as material properties for pre-stress. So all of anything that we have a standard pre-stress beam for, we have the material property combinations in here as well. So that's what the new library items are for. So that's just what I quick wanted to share. We just got that updated yesterday, so I'll add an email letting everybody know that here with more description later. But yeah. So with that, I will pass it on to Pro Miles. Thanks, everybody.
Great. Thank you, Sean. All right, so today we are going to be covering creating a pre-stress I-beam bridge from scratch. So this would be, as Sean mentioned, there are templates for the standard bridges, but if you are creating a bridge that's not a standard, this would be the approach that you would take. So we sent out this tutorial, and so this is the tutorial that we'll be using for the training today. You should have also received an email with a temporary training license. So please feel free to follow along and work through this example. We also wanted to make sure we blocked out enough time here for questions as we're going through this. So if you have any questions as we're going through, please feel free to send them in the chat, and we will pause periodically to answer any questions you may have. So with that said, we will get started with the pre-stress 1 tutorial. You'll see the first couple of pages here have some information about...
Hey, Carolyn, you're not sharing your screen.
Oh, thank you. All right, will you see my screen now?
Yes, we can.
Okay, great. Thank you. Yeah, so all right, so this is the pre-stress 1 tutorial. Like I said, this would be in the emails that you received prior to the training. So these first couple of pages here, we have details for the structure that we'll be modeling, elevation and typical section dimensions, as well as information about the beams and strand patterns and pre-stressing. This will be a single span pre-stress I-beam bridge with harped strands. So we can go ahead and start modeling the bridge. So to create the new bridge, we'll go ahead and click new. Similarly to the structure type, that we did in the last training. The last training I think many of you attended was for creating the steel bridge from scratch. So you'll see there are a number of things through this that are similar to for different structure types within BrR. Hold on a second. Is this working? There we go. All right, so basically we'll go ahead and just start out by creating the bridge alternative here. And we can uncheck culverts here in Bridge Workspace view. Again, all this is going to do is basically just hide the culvert definitions here in the bridge tree, since we won't need that for this structure. And we can go ahead and click OK to apply and close. If you ever need to get back into that window, that is right up here at the top of the Bridge Workspace tree. So you can come back in here if you do need to make any other changes. And then keep in mind as well, the other fields that you'll want to fill out here for the Iowa DOT fields. As Sean mentioned, there will be the new custom agency fields, and you'll also have counties and other information about your specific bridge. All right, so similarly to the steel bridge that we did in the last training, the first thing that we're going to do is go over to the components tab and create the components that we'll be using for this bridge. So we're going to start out with the concrete. All right, so for this example, we're going to go ahead and enter the values up here, and then we'll use the compute button to compute the rest of these values. You can also always copy from library, select a material and modify it if you want to, and then you can recompute based on the modified values. I'm going to go ahead and cancel out though. For this example, we will just we're going to enter the properties here directly for this concrete. All right, and then again, we can use the compute button to populate the rest of the properties here based on the AASHTO values. And we can go ahead and click OK. So that saves this concrete that we just created to this bridge. If you did want to save this to the library in BrR so that you could use this same concrete for other bridges, you can also use this copy to library button. This is telling me that that is already in my library. So I'm going to give it a different name. And it'll show you can copy that material to your library if you do want to be able to then access it within other bridges in your database. So similarly, we're going to go ahead and create the deck concrete material. Click OK, and then again, that saves that concrete to this bridge. So then we'll define the reinforcing steel and the pre-stressing steel. For these, we can use library items here. So for the reinforcing steel, we're going to go ahead and select this grade 60 reinforcing from the library and save that to this bridge. So again, that's basically making a copy of that library item, saving it to this bridge. So if you do want to modify that copy of the library item, it modifies it for this bridge only that it's saved to, if you're modifying it through the bridge workspace. So then we're going to do the same for the pre-stressing strand material. So we have the 1/2 inch 7-wire 270 KSI low relaxation. Right. And we can copy that to this bridge. All right, so then the next thing that we're going to add is the beam shapes. So we're going to go to Prestress I-beams. And again, you can either double click in the tree or you can select and click new. So we're going to create a new I-beam shape. And for this example, we're going to use the AASHTO PCI BT72 bulb T, which is a wide flange beam type. And that beam is populated in the AASHTOware library. It's a default beam type. When you have the system and library files from Iowa DOT, you'll also have the Iowa beam types as well that you can select from. The AASHTO beam types are in the BrR software library just as default. All right, so when we've brought that in from the library, it populates our dimensions and properties, and then it also populates a strand grid here. And so that that'll allow us to add pre-stressing later when we get the member alternatives created. So the library items will contain like the dimensions and properties as well as the potential strand positions that you'll be able to locate strands. So the next thing that we will create here is the appurtenances. So this bridge has these concrete parapets. Again, the Iowa DOT library files contain a lot of standard appurtenances, so that's always a good place to start and check to see if that appurtenance is available in the library. For this example, we're going to create a parapet that is not a library item. We're just going to create a new one. And the unit load. So this creates our parapet definition. We click OK. And again, that saves the parapet to this bridge. Again, you can, uh, definitely check the library items, I guess, before creating the new appurtenances, because a lot of the standard appurtenances are included in those library files. All right, so once we have the components defined here, We can go back to the bridge tree here in the bridge workspace. And we will create a new superstructure definition. So again, this is going to be a girder system superstructure, since we want to model all of the beams in this bridge as a system model. Um, so this is our girder system superstructure definition window, which again is very similar to like the steel bridge and the other structure types we've worked with. So we'll need the spans and the beams as well as the span length. And we'll select pre-stress for the member alternative types. Just to point out as well in this window, this is all we need to do for this structure type. There are some additional options here for analysis options. Similarly to how we discussed with the steel bridges, you can run a 3D finite element analysis when you create the girder system for the pre-stress bridge types as well. Again, it probably is not something that you would need to use very commonly for pre-stress beams, but that is there. As well as the specs tab that allows you to select different versions of the AASHTO spec in the event that you do want to evaluate or compare differences in spec versions. So once we have this window populated, we can go ahead and click OK. And again, to reopen that, then you'll just go back to the superstructure definition at the top of the bridge tree there. All right, so before we go ahead and set up the actual bridge, we are going to create the bridge alternative. Again, you don't have to do this at any particular point in the process. You can do it when you're creating the bridge, when you're done creating the bridge. But it is important to do to ensure that this bridge and the components that you're defining here will be included if you run a batch analysis from the Bridge Explorer. So this is really important for permitting and batch analysis. So we will go ahead and define the bridge alternative right at the start here. And so then once we have the bridge alternative and we then create the superstructure here. And then this is where we will select the superstructure definition that we want to include. One thing to note one thing to note is here we go, girder system. So we're selecting this girder system here to be included. The one thing to note is, so for this example, we have like a single span pre-stress bridge. If you did have, let's say, a pre-stress bridge that was multiple spans but not structurally continuous within the same bridge or the same structure number, you can define those as individual superstructure definitions, and then you can add all of those to the same bridge alternative, and so that'll allow all of those to be included then when you run the batch analysis. All right, so once we've got our structure alternative set up, we'll see that this now defaults to being selected here for this bridge. So that looks good. That means that this will be included here when we run any kind of batch analysis or permit analysis from the Bridge Explorer. All right, so once we've got that set up, we'll go ahead and create our superstructure. Um, Again, we don't have to modify or do anything in the impact dynamic load allowance window. This will default to AASHTO impact values. Um, for the load case descriptions, you can either add default load case descriptions or just create individual ones. So for this example, we'll create load cases for our parapets and future wearing surface. And then, keep in mind as well, a lot of times in rating, you'll want to look at that actual wearing surface. This example just includes future wearing surface, but we'll select the load type here for DW. And we've got our load case descriptions defined. All right, so then we will continue to the framing plan. So we've got our girder spacings here. And then diaphragms. And for this example, we're going to use the diaphragm wizard. You can either click new and just enter those diaphragm locations directly. Diaphragm wizard can be helpful for some bridge types. Since this bridge does not have a skew, you'll just see one option here. But if you do have a skewed bridge, you'll see a couple of other options here on kind of the patterns for diaphragms that can be selected to use with the wizard. So for this example, we're just going to say 2 equal spaces along the span. Again, in general, you do also want to enter your diaphragm loads as well so that those are included in your analysis. And so you'll see then this populates the diaphragm locations here. So once we've set up the framing plan, we can review and check using the schematic. And to get to the schematic, you can just right click framing plan and then you'll have schematic there. So we can see we've got our spacings and diaphragm locations and everything looks as expected. So then we will move on to the structure typical section. So we're setting up the deck width and overhangs. And then we'll go to the second deck tab. And here's where we'll select the concrete and set the deck thickness. Again, this deck thickness here is used to compute the dead load from the deck. Similarly to the steel bridge, if you have a composite bridge deck, you can set a separate structural thickness later when we're setting up the member alternatives. So again, the deck thickness here will be used for dead load calculations. And then we'll go ahead and set up the parapets. So since we only have the one parapet appurtenance type defined, it'll automatically show up in this window. if you have more, different type, let's say you have parapets and a median, or, I don't know, well, like median is a different tab, but if you have, multiple of the same type of appurtenances defined within that bridge, like, so save to this components tab, then you'll see all of those in the drop down, so you can select from the ones that you have saved here. When you get here, if you do want to create a new one, you can do it through this create new appurtenance, or you can just go back to the components tab, add it there, and once it's added, it'll show up in the drop down. So we'll select the load case name. And the locations for the parapet. And then we don't have other appurtenances for this example, but you would, do similarly for medians, railings, generic appurtenances, or sidewalks. Again, for all these different rail types, do check the library items because a lot of the standard ones are included there. So for this bridge, our only appurtenance is the parapets, so we can skip ahead to the lane position tab. Once we've told the software, how the width and, dimensions of the bridge, as well as like the locations of the parapets, the software now has enough information to compute the travel ways or the lane positions within that structure typical section. You can also just manually enter this if for some reason you wanted to, define a travel way in some other way. But you can either manually enter these values or use the compute button here. Right, and then the last thing for our typical section is to just enter the wearing surface. And then we can go ahead and click OK. And then similarly, we can right click structure typical section and view the typical section schematic to just ensure that everything looks as expected here. This looks good. Like I said, we don't see the beam shapes yet since we haven't assigned those to member alternatives. Again, if you do enter this info here and you notice in that typical section that something looks off, one common thing is parapets getting flipped around and things like that. So you can make those adjustments, and when you click apply, you'll see the changes made in here. So that can just help to ensure that everything is where it should be within that typical section. So we've got the parapets, the travelway, wearing surface, and the concrete deck. All right, so the next thing that we will define for this bridge is the concrete stress limits. And so this is going to be based on the beam concrete. So on this drop down here, we want to select the concrete that we're using for the pre-stressed beams. And we can use this compute button to compute the AASHTO values for these stress limits. Again, if there is, for some reason, you do want to override those, you can. But the compute button will compute the AASHTO values. And this one we're just entering for the slab because this is these computations are based on the material that we selected here for the beam. So we can click OK, that'll save our stress limits here. And then the next thing is we'll do pre-stress properties. And so we'll just need to go ahead and enter the additional information here on this window.
And Carolyn, we do have a question in the chat.
Oh, okay, here. Just look here. Sidewalk tab, also just for deadload calculation. If I have a pedestrian lane adjacent with vehicle lane on a deck, should I define them here? Oh, okay, good question. Yeah, so let me go ahead and apply this and we'll go back to this typical section window for a second here. All right, so I think the question is as far as the sidewalk tab for dead load and I guess like lane positioning. So this is basically you can set this up. There's different ways that you can do this. So if you put a sidewalk in here, and let's put a sidewalk in here. All right, I'm just putting in some kind of random values here. But so I put a sidewalk in here and it positioned it right there. Now, if we go to the lane positions tab and click compute, this is, hold on a second. Yeah, so this is now computing a different travel way. So if I apply that, you'll see it moves the travel way so that it's basically not on the sidewalk anymore. Now, there may be cases, and again, this is a, engineering judgment thing and it's going to depend on your bridge, but there may be cases where you have a sidewalk and you want to include the weight of that sidewalk, but it may be like a vehicle mountable sidewalk. So there's still a potential for vehicle like traffic to be in that area as well. And so you can always just manually set your travel way here. And so if you do this, then you'll see the travel way is now overlapping the sidewalk. So for this case, you would have the dead load from this sidewalk, but you would also be accounting for the possibility that a vehicle could be there. So basically you can do it either way. But it kind of comes down to engineering judgment or, DOT preference or, the configuration for that specific bridge. But yeah, if you put a sidewalk in there, it'll account for the dead load of the sidewalk, and then the travel way is what'll tell the software where vehicles can be positioned. Um, does that answer the question?
Just let us know if it doesn't, or if you have a follow-up. Thanks, Carolyn.
Okay, thank you.
Does the
Oh.
sidewalk thickness matter? Follow-up.
Well, that'll be used for the dead load. Yeah, that'll be used for the dead load computation. The software isn't going to make a determination of whether or not a vehicle could be positioned on that sidewalk based on the thickness. That's something that would be an engineering, judgment as far as, where you position the travel way. But yes, the thickness of the sidewalk will be used for the dead load calculation. So. Okay, well, yeah, if there are any other follow-up questions on that, please let us know and we'll be happy to discuss. I'm gonna take the sidewalk back out of here just so I end up with for the results here for this bridge. All right, so I took my sidewalk back out. All right, so we've got our framing plan, typical section, concrete stress limits, and pre-stress properties defined here. So then we're going to go ahead and define a shear reinforcement definition. And so we'll be able to use this then for all these different beams that we'll create here. So this will be a number 4. Number 4, shear reinforcement. And again, we've got the grade 60 material here because we added it in the components tab. Similarly, with these other library items, you can either create another one from here, or create it here in the components tab. And when you do that, it'll show up in this drop down. So we've got our material and bar size, number of legs in the beam cross section there, and the angle. So we can go ahead and click OK in that. Whoops. Okay, I've never seen it do that before. My bridge tab is gone. All right.
Carolyn, try. We changed this in the newer version. This is still 7.5, but it close out your workspace, the whole panel. Click that, and then go ahead and go back to the view, and then hit restore layout. Interesting.
Yeah.
Did you pull it off by accident?
I may have. I clicked. Oh, here it is. Okay, I think I
Yeah.
just
Just close it out.
expanded it.
We'll close those out, and then it will go back to the dock. Yeah, try clicking that.
Oh, there we go. Okay.
Well, you have to drag it back. You'll have to drag it back in too. I think you must have dragged it out.
Yeah, there we go. Okay. So I dragged the, okay. I'm sorry about that. Yeah, so
Yeah, drag it down to that little square that appeared. So, yep, right now drag it down, yep, and it will click. And then do the same thing for the other one.
all righty.
There you go.
Thank you. Yeah. Yeah, I will
I think the newer version of BRDR, just so everyone's aware, I think the newer version, whenever you click restore layout, it'll also restore the tabs too. I think we were just restoring the panels in this older version, and then it does something different now. So
yeah, and I'm not even sure. I clicked something kind of weird there. I basically dragged, I think what I did is I dragged this tab out of the workspace, then expanded it and then minimized it. But
no, that's okay. That's a pro tip. So now everyone gets to see how the tabs work. So they learn something in the process.
yes. All righty. And then I guess just to mention too, as I'm showing these, I tend to kind of move these to look at the different schematics or other things here. You also can pop these out if you want to move them out or expand them, or look at them on a separate screen. Again, you can redock those the same way. So you can do that with schematics and other things as well. If it's helpful to be able to view those things. And then restore layout will resize everything. So, alrighty. Okay, so we've got the shear reinforcement defined. We've got the bridge workspace tabs back where they're supposed to be. So we can go ahead and create our pre-stress beam member alternatives. So when we created the girder system and specified the number of girders here, that's what basically populates the number of members that we have here. So we've got 6 girders for this bridge. We're going to go ahead and create the first one here. So we just expand G1 and then double click member alternatives to create a new member alternative. And so for this one, we're going to be doing pre-stressed concrete I-beam. So we select both of those, and click OK. One thing just to point out is that some of the options that'll appear in this member alternative tree that we'll see get created in just a second here are going to be a little bit different based on the different shape that you pick here. So just make sure to, select the one that applies for the bridge that you're doing. You can always, go back and add a new one and remove it if you click the wrong one, but it will show some different things in the following windows based on the one that you pick. All right, so this is basically just the member alternative window. Again, there are a lot of similarities here for different structure types. There are some differences between, pre-stressed and like the steel one that we did before. But similarly, you do have this specs tab where if you want to evaluate, different spec versions, you can do that. You have your factors here. We're not really doing anything with either of these tabs, but you also do have the control options here for the pre-stress beams as well. For this example, we don't need to make any changes here, but always good to look this over when you're creating a new structure, because there are, a number of different options here on how that structure will be analyzed. Again, you can also refer to some of the Iowa DOT documentation for some information on that as well. But again, anytime you are creating a new structure, it's good to review this and make sure that whatever you're selecting here is appropriate for that structure. So no changes required there for this example. We can go ahead and click OK, and that'll create our member alternative. Just a second here. All right, so again, there's nothing that we are going to need to change here for member load supports or default materials or impact. But again, you do have this member loads window here where if you do have, an additional load that's not included in like that structure typical section or, the member self weight or anything like that, like if you had an attached utility line or something like that, you could enter that load here in member loads. And then supports as well. This is defaulting to pin roller, but always good to review and just make sure that it is appropriate for the structure that you're modeling, but no changes required for this example. All right, so like we said, the impact, again, is going to default to AASHTO standard. Not too many reasons to change that. So the first window we'll go to here is the beam details window. And so this is where we're going to kind of set up some more of the specifics on this beam. So we're going to select the BT72 beam shape that we added in components and the beam material, the 6.5 KSI concrete, and then the pre-stress properties. Again, this is, if you do have a bridge that has, maybe you have different, you have like maybe a multi-span bridge with different beam types and different spans, you'll just want to make sure you select, the properties and everything that match up with, that beam. And then we have the beam projections here. And I'll just take a minute just to point out too, a lot of times the beam details window is one where you will, where you will want to probably check that F1 help menu. So this will tell you some more information here about what this is looking for. So beam projections and where that's measured from, and what it's needed for. So basically end of beam to center line of bearing. There's one other thing. We'll do these other couple of tabs, and then I want to point out one other thing that's not in this tutorial. All right, so we've got this band detail here. If this is left blank, the program will compute it, so we can leave that. And we'll go ahead and set up stress limit ranges, and we'll just say for the full length of the beam. So, so this length is the full length of the pre-stressed concrete beam. You'll remember we had the span length that we set up was 120 feet. And then here we have 6-inch beam projections on each end. So that gives us a total of 121 foot pre-stressed concrete beam. So then we just define the slab interface information. And if you have a web end block, you can enter that here as well. For this example, we do not. So once we've set that up, we can go ahead and click OK. The one other thing I want to mention that's not in this example, but I just want to point out, if we have a bridge like this, okay. So this is a similar bridge, but it is multi-span and it's made continuous. It's simple span for dead load and it's made multi-span continuous for live load. And so for this type of a bridge where you would have, let's say, multiple spans within the same structure definition, when you go to this beam details tab, you are going to see a couple of other things here that we don't see for the simple span. So one of them is the continuous support detail here, and the other one is the continuity diaphragm. And so this allows you to define information here on the offset between those spans, as well as information on continuity diaphragm if you are choosing to make that structure continuous for live load over a multi-span structure. Again, the F1 tab, the F1 help menu for these windows as well has some additional information about exactly what these dimensions are looking for. So I just wanted to point this out in the event that you are modeling that type of a structure. All right, so back to our bridge here. We got the beam details and the we do have mild steel here if you want to enter that. We don't need to, I think, for this bridge. But we are going to go ahead and set up the strand layout. Okay. So I don't know. I hope that you can see this. I know the text might be a little small here. But basically, so we have our beam, and then this beam is showing the possible strand locations and that are defined in the beam component itself. So the strand location, the little X's here, are the possible strand locations, and those are defined in the components in the beam shape itself. So if for some reason you ever needed to change that, which again would probably be pretty uncommon, but if you're setting up, a structure from scratch, this is where the strand grid is defined that then populates the possible positions of existing strands when you get to this beam window. So so for this structure, we are going to define the strand rows, and we'll select harped here so that we can define the harped strands. So the first thing that we'll do is is, so these radio buttons will allow you to select the location that you're defining strands at. So we're going to define the strand positions at midspan. Now to do that, you can click or, click again to unselect here. Or you can click and drag to select multiple strands. So basically, if I click here and then drag to select this strand group, these then have the little circle around them, so they're sort of highlighted. And then you can right click and then you can say add a strand at the selected positions at this location. So this is saying at midspan of the beam, we're going to say this is where this group of strands is positioned. So let's see, 3, 4, 5, 2, 3, 4. So I think I got an extra row there, so I can go ahead and just unselect those. All right. So this is our beam cross section at midspan. Then we can go ahead and go to the beam end. So since we have symmetry checked, we can just define left end, and left end will be same as right end. If you did have a difference, you could uncheck symmetry and define the left and right end separately. But the next thing we'll do is define the end strand pattern. So we'll put in the distance for the heart points. And then we're going to go ahead and select the strand position at midspan here. So again, you can click these here, and so then this will basically show this strand is harped at the end, and then you'll see they're gray instead of black here, and so that corresponds to this. So this is saying this is the midspan position of the harp strand. This is saying the harped position of a harped strand. The one thing just to keep in mind when you're doing this is that it won't let you cross strands. So let's say I do those two and then I do these two and then I want to go back up here. It won't let me do that because it's basically saying that the second one I click down here is the second one in this row. So it's associating this position with this strand. So, whoops. All right, hold on. Okay. I don't know what I just did here. One second here. Okay, I'm gonna just cancel that. All right. All right. So going back here, like I said, you do want to be a little bit careful when you're selecting the harp strand positions, because like I said, it won't let you cross the strands. And so that was basically what it was telling me just now. And so I kind of wanted to just show for demonstration purposes, but I want to just re-enter this real quick here. So like I said, you'll want to start at the top because it's going to associate this row of strands with the ones you're pulling up. So you can click and drag to select those strands and harp all of those strands, or again, you can do it individually, but you just want to start at the top of the position because it's associating that with the top row of strands. So, all right, so there we go. Okay, so now we've got our strand pattern defined at the midspan as well as at the beam ends. And we can go ahead and click OK. And then the next thing that we will do is the depth profile. 1 second. I guess just real quick, let me just check the chat. I want to make sure we're not missing any questions or anything. Um, okay. Okay, so we've got deck profile. So like I mentioned earlier, for the structure typical section, when we define the deck thickness there, that deck thickness is used for dead load. When we're in the deck profile here, this deck thickness will be used for structural properties for a composite beam. And then we will go ahead and um, similarly, we'll define the haunch profile. Um, all right, and then we'll set up the shear reinforcement ranges here. All right, so we'll see here that this includes the shear reinforcement definition that we created here in earlier in the superstructure. So this number 4 shear reinforcement that we defined here can be selected there. And then the way that the shear reinforcement is defined is basically that um, the shear reinforcement is positioned like at the end of the spacing. So we have a start distance with a number of spaces of 1 and a spacing of 0, just to ensure that there's one reinforcement bar put at that start. And then these go from there. All right. So the next thing that we have is the live load distribution. Now for pre-stressed bridges, it does need some info about the beam next to it to be able to compute the live load distribution factors. So if I go in here and try to do that now, I don't think it'll let me. Right, so it's telling me it'll basically give you this error and tell you it needs information about the beam next to it before it can compute that for you. So um, again, you can copy and paste between member alternatives within a bridge. I mean, a lot of times, I mean, most all the time with pre-stressed bridges, you're gonna have the same, the same beams here anyways. So you can go ahead and just copy and paste this beam into the next member. And we can go ahead and add it to the rest of them as well. But this distribution factor calculation, I think, is just looking for the adjacent beam. All right, so once we have that second beam in there, we can go back to girder 1. and go back to live load distribution. And this will, this should be able to compute the distribution factors. Again, I wanted to mention as well, you know, if you if you don't compute and save the distribution factors here, then they'll just be computed at runtime using the AASHTO distribution. And so I believe that's how a lot of the templates are set up, is to compute them at runtime rather than compute and save to the structure. But we can go ahead and compute these distribution factors here. So we'll just show how they're computed. All right, so we got that to compute, and then we've got deflection moment shear distribution factors. And you can click this view calcs button to see like a detailed breakdown of how those distribution factors are calculated. So it'll look at, you know, the AASHTO distribution factors as well as like check ranges of applicability, do lever rule when appropriate, and it'll show you, you know, which distribution factors it's using and why. So if you want to save those to the structure, you can click apply or OK to save those to this bridge. Again, if you don't do that, then it'll compute those at runtime.
Hey, Carolyn. Hey, can you read that? There's a question in the chat here. Could you try to take a stab at that? And I will say, Matthew, that question probably should be submitted to our support, and we could give you a more lengthy answer, because it can get complicated. And there have been requests to improve this feature in BrR. But Carolyn, if you want to read his thing and maybe give your response, you're better suited than me.
Yeah,
Sure.
Jeff. Yeah, Jeff, I think that's a good point. And we also do include everything in the spec article as far as how this loss calculations are done. And there are multiple options for loss calculations. So if there's something you disagree with, or there's something in the loss calculations that you disagree with, we could have a discussion about that as well.
Yeah, I'm just reading over the question here. Sorry, just give me 1 second. Calculate some options on that here. So, for lump sum entry best practices. Yeah, so I think this may be something that we want to follow up with on support, but I guess just the sort of quick couple quick things to mention is so when we were back here in this pre-stress properties window, we have the AASHTO approximate loss method. The question here is about computing losses differently. So we do have lump sum loss and this PCI. So, and then here you'll see there's, like we said, a few different methods on computing losses. So there is some information here in the F1 help menu on some of the different things that you can enter for these different options. And then also there should be some additional information in the method of solution as well. And I know a lot of you were in the other trainings we've done where we've pointed out this method of solution stuff, but I do want to just mention it again just because it's it is important. So for this bridge as well, we can go to bridge workspace and then over here to the LRFR and method of solution. So just even kind of skimming through here, there will be some, well, maybe it should go to table of contents. Yeah, because this has a lot of different structure types in here. So there should be information in here that does talk about pre-stress losses and the different methods that can be used for that. And then, like I said, too, that should also be reflected in this method of solution as well as like our flow charts and stuff. Yeah, so yeah, I think sorry, hold on. In tutorial. Okay. Oh, okay. We have another separate question here. Okay. Um, yeah. So for the losses, like I said, there are different methods that you can use here. The ASHO approximate, lump sum, these other methods. We can certainly, if you have like a specific example or a specific case where you're not able to get it to do what you want it to, please do send it to support and we'll take a look at it. And then we can also look after we run this analysis, we'll see in the spec articles some information about what it's doing. So we'll show you where you can find that information as well. Um, all right. So the other question that I saw just come up on here, all right. The other question that I saw just come up here in the tutorial document, the checkbox in the live load distribution tab is asked to be unchecked. Yes. Okay. So, all right. So in this live load distribution tab, there's this checkbox here for allow distribution factors to be used to compute effect of permit loads with routine traffic. So before I computed this, you'll see there, well, here, let me just delete all this and then we'll show it again. And I'll show you the other part. Okay. So when you first open this window, this box isn't checked and there's nothing here. When you do the compute from typical section, it'll do that computation and then you'll see it also checked this box. So the reason for that is when you're looking at combining permit loads with routine traffic, there are a couple of equations here that have, here, let me just, hold on, I do have this, just give me 1 second, and I want to find the equation. 46225. Okay, here it is. Okay, so 46225. Okay, so this has this goes back, it checks basically a couple of conditions of applicability for this, I guess, method of combining permit loads with other traffic. So basically it's saying there are a couple of conditions here, lever rule for single and multiple lane loading, as well as this additional article. And it's saying, if you don't have those scenarios, you can use this method of combining those loads. So when you do this compute from typical section, the program checks those conditions and then it'll select this checkbox if it meets those conditions. And so that's basically just saying, yeah, it's okay to use that, method of load combination. Now, the reason we have the checkbox here, from what I understand, is that, the user also can input your own distribution factors. You don't have to compute them from the AASHTO calcs. And so if you do that, it would be up to the user to check, select this box if it does meet those requirements or not if it doesn't. As far as this specific tutorial, I am not sure why it says to uncheck that box, because that's really all that box does, is it indicates whether or not that bridge meets the requirements for the load combination method that's described there in 46225. I think it may just be that for this example bridge, the tutorial doesn't go through doing like a permit loading combining with adjacent vehicles. So it may be that the tutorial is just saying uncheck that because I guess that analysis isn't included in the tutorial. But ultimately all this checkbox really does is when those factors are computed, it also checks whether or not this applies and checks that if it does or does not. So I don't know if that answers the question, or if there's any other information on that we can provide. Good, thank you. Alrighty. Alrighty. Good. Yeah. So like I said, this really doesn't make a difference for the purpose of this tutorial that we're looking at. So um yeah. So we'll leave it checked. It'll do the same thing since we're not running the permit vehicle. Okay. All right. So the last thing that we've got here on this girder is points of interest. We've talked about this when we did the training on some of the templates where we talk about how to enter deterioration and override different capacity related things based on the actual bridge condition. So this window does have some things that you can override if you need to reflect some sort of deterioration or other kind of unusual condition with your bridge. For this example, we don't have any changes to make in that window, but just to point out that it's there. All right, so let's see. Okay, so we've got the bridge set up there with our girders, and we can go ahead and run the analysis. So I'm just going to rate this first girder here. So I'm going to click to highlight the member alternative that I want to rate there. We'll go to the design rate tab and analysis settings. And then you can always just individually, select vehicles. But we're going to use the templates here. There are Iowa DOT templates, so you will be using those generally, which again are in the system and library files that Sean had mentioned earlier. For this example, we're just going to use one of the AASHTO templates here. So we'll select the LRFR design load rating. And then we'll see that this gets populated with the design vehicle. The other thing I want to just mention too on this output, there are different options here on, what you want to see in the output. So this is, I guess, I don't think we really need to make any changes here, but you can select and unselect some. Actually, I don't know why these are all unchecked. But you can select or unselect different output reports here. And then this one for the concrete articles will give you the detailed concrete output. All right, so we've got our design vehicle there, and we'll go ahead and run the analysis. Let's pull this back up. Again, you'll see here some informational messages that get populated as as the analysis is running. So you can always review that. The other thing just to mention is you can also see like information here. There is also in this workspace this validate button. This will also show you other warnings and things that you'll sometimes see here as well. Okay. So yeah, always good to review this. Sometimes it's not stuff that you actually need to enter. So like for this case, it's just saying there are no LFD single lane or LFD distribution factors defined. That's fine. Like I said, if we ran the LFR analysis, it would compute them at runtime. So, and yeah. Okay, so once we've got that analysis run, we can go ahead and take a look at our results here. So we've got tabular results, and this will give us basically inventory and operating for the different HL93 configurations that were included there, as well as like the controlling limit state and location. So that's our summary. We can go to the spec check detail and expand this down, and then you can look at the detailed results for basically all of the different computations and AASHTO specification checks that are occurring here. And so then you can see either like informational, not applicable, or pass fail for all of these. Double click and you can see all the computations that go into these different checks, as well as the references to the AASHTO specifications, the factors that are used, the loads that are generated, all that. And you do have this by load stage, and then you also have some additional info here for the pre-stress calculations. So just going back to just briefly touch back on the question earlier about the different methods of pre-stress losses and load stages, you can, when you run that analysis to try and, look a little more closely at what it's doing, when you come in here to the spec check, you can, in addition to the spec articles that you see here, you also have additional pre-stress calculations that you can look at the different stages for, with some additional information about kind of what's happening at each stage. So there is quite a bit of information there if you want to basically kind of like evaluate one method against another for different ways of entering pre-stress loss information, or things like that. That would be where you can find more information there if you want to really dig into what the program's doing. And then again, we do also on the engine outputs, you can see, you'll get this summary of the spec check results. And so this will basically provide you with just summary information there. Okay, we do also have results graphs here too, just you can see, you'll see like dead load and pre-stressing force. This is all here as well. So that covers the rating analysis. The one other thing, I guess, just to mention is like in the tutorial does also mention an LRFD design review. So that just runs, similar to a rating analysis, but it just runs a design review analysis. If you are using the temporary training license, I believe you should be able to run that. But again, that's more on it's a BRD design feature as opposed to rating analysis. So just wanted to mention that since it's in the tutorial. So I think this covers most of what we had here. We've got a little bit more time here. Do we have any other questions or anything? I just want to check the chat here and make sure we didn't miss anything.
I think we're caught up on the chat, but if you have a question, please go ahead and put it in the chat.
Hey, Carolyn.
Hey, yes.
I know when we were doing the templates, we had a scenario where the pre-stress strands started on different rows at the top of a harped thing, but then by the bottom they combined into the same row, and we had to tweak the beam to kind of fudge that a little bit to make it work. Do you remember that? Would you
Yes, I
mind,
do.
in case they have that same scenario, would you mind maybe showing them how you did that?
Oh, sure. Okay. So yeah, so this was sort of this is I guess a strand pattern configuration that isn't like it's not I guess directly supported in BRR, but we make it work. So this comes back to kind of what I had mentioned before about not being able to sort of cross strands or pull two different strands to the same location. So for the example that Sean's talking about, it would be like let's say you have instead of these two rows being separated, they're sort of bundled at that location, but then when they get pulled up and harped up, you have, the two separate rows up there. So what we did to make that work is basically this comes back to these potential strand positions here that get set in the beam library item itself. So if we go back to, let's see, I-beams. I'm just going to open a random one and see what we have here. Okay, I don't think this one has it set up that way. But basically what we did is, so we have like the number of strands that you can have per row, and then the vertical distance from the bottom and horizontal spacing. Um, so what we did is basically add in kind of a second potential strand row location that was approximately at that same height. So let's say sorry, this is like showing all these things when I hover over it. Let's say we were to go, I don't know, here, and we have this row of strands that's 6 inches from the bottom, and we wanted to do like that type of bundled strands. For that template, basically we added an additional possible strand position that's just like, 0.1 inches off as a vertical distance. And so it basically represents that group of bars that's bundled at this vertical distance from the bottom at the middle of the beam, but then expanded to the harped positions at the end of the beam. And so I'm trying to remember, I don't know what beam type has that. I don't know if this is going to have it. Yeah, I don't think these ones have it. But essentially it's adding in an additional row that's just very, very close to the same row. And so then what ends up happening is when you're in this here, I'll just do it in here just to show how it works. Okay, so I want to add an extra one here at like 10. So I'm gonna do like 2. All right, so this is basically adding an additional possible strand location that's almost exactly at the same location as this row of strands. So when that's in there, and I come back over here into the strand layout, see, 3, 4. That should be right here. Yeah, this is sort of a workaround to make this work. So I'm trying to do this on the fly here. May not work as smoothly as I'm hoping it does, but we'll see. Oh, that's not what I wanted to do. Okay. Try that again. All right, so these are the harped positions. I probably shouldn't be trying to do a live demo on this on the fly. I think the reason it's not letting me do it this is because I added that in after I already had the strands here. So I think that's what's creating the issue. But what it really comes down to is that when you add that additional strand row that's basically right at that same vertical height, or very close to that same vertical height, you can then you can then harp the strands in those 2 rows up to different harped positions. So I don't know how well I'm explaining that. If there are any additional questions about that, we can certainly provide you with more.
Sean, would you want us to put together a little demo, a quick demo to do that sometime for everyone?
Yeah, sorry, I didn't mean to put you on the spot there like that. But I think I don't know how frequently an issue it is. We had it with some of the standards. If you run into it, you can email me and I can find an example of how we did that. Or if I'm getting a lot of emails or something, then maybe we can talk about putting a little demo together. But I just wanted to raise that because I know that was something that came up when we were doing the templates. So
Yeah,
yeah.
and I think, like I said, I think okay, this might actually show it now. Or maybe not. Yeah, we definitely have beams that have this defined, and I think we probably have like an email somewhere too, sort of a description of it. I think just right now it doesn't want to let me do it since I had already assigned strands to here. But all it's really doing is saying you have strands that are bundled at this location, and it'll allow you to harp them up to the different locations.
Okay, and we have a couple of questions in the chat.
Yeah.
The second question is
Oh,
related to double clicking on
this is
specification refs. Yeah.
yeah, that's this.
Yeah.
So when you're running an LR, so double click and open a specification reference in the spec check tab, it doesn't open. So when you're running concrete structures on this output tab, you can select here to turn that on or off. And that's just, it generates a lot of output. It sometimes can take up a lot of time or space. So you can, when you want to go, so if you're, let's say, just, running a permit vehicle on a model that you're created and you're happy with and all that, you may not want to generate all that output. When you're going through the model and you want to look, you want to look at all the detailed output, you can go ahead and select this. And so if you run it with that selected, then that should allow you to open up all of the specs in the spec check tab. So if you have that box checked and then these don't open, then that would be that would be a bug. But I think that's probably what's causing it.
Just rerun it again and make sure you have that box checked and let
Yeah.
us know. You could let us know in the support board if it's still occurring. But that's typically, we see that issue pretty frequently. So
Yeah.
just make sure you have that checked.
Yeah. And just again to point out where that is, so that you get to that through analysis settings and then this second output tab, and then it's this one right here.
Another question was mention where you can find the point of interest tutorial. I guess yeah.
Yeah, so the last we did a few previous virtual trainings. It wasn't specifically a tutorial about points of interest. It was the it was when we worked through the modifications for the Iowa DOT template models to add deterioration and additional loads and stuff. So those previous trainings did cover a few things with entering data in the points of interest window. So it wasn't specific to that, but it did include some information. I will say if you want to learn more about the different options and points of interest, I would say there definitely start with the F1 help menu. This will give you a bunch of information about the different things that these items can do in terms of overriding values at different analysis points. We may have some additional tutorials on our site that cover those. Off the top of my head, I'm not sure, but the tutorials that I was referencing were just the previous Iowa DOT training on modifications to the templates. Right, I don't think I'm seeing any other question. Oh, here we go. On the pre-stress I-beam input under the properties tab, can you explain the selection box used under section properties and how analysis option line girder or 3D FEM impacts what section properties are used in the analysis? Um, Okay, so in the pre-stress I-beam properties, use entered section properties. Oh, okay, hold on. I got to think about this for a second because this is one of those things where they're used there. I think used to be a different engine that handled this differently. Sorry, what were you gonna, Mark, were you gonna say
I was
something?
going to say hit the F1 key because I think we maybe have a description in there.
Yeah. I think that just oh, it's probably the engine related help here. Okay. Use entered, yeah, here it is. Okay, so if we go to help and then engine help, okay. Um, if use entered section properties is checked, the entered section properties will be used for the finite element analysis and dead load computations only. Spec checking will be done based on computed dimensions entered in the dimensions tab. If use entered section properties is not checked, it'll compute the section properties based on the dimensions entered on the dimensions tab. Um,
Yeah, and this is what it does for the ASHTO engine specifically.
yes. Yeah, and that was what, yeah, that's what I was just thinking about that one because I think a long time ago there was a different engine that handled something a little bit of a different way here. So I wanted to just um make sure on that. But engine related, yeah, see engine related help. Yeah, so that's this engine. So where it says here, you see engine related help for analysis engine specific information on the use entered section properties. So to get to that, and this is kind of a, yeah, this is kind of a confusing one, but so I go to the F1 help menu, and then you see here it says section properties, but it doesn't really tell you that much. But this note here is saying go to the engine related help. And so that's where it'll give us this information because it's specific to that analysis engine. Okay, another question, follow-up question on the sidewalk. We should not define another vehicle and travel way for the sidewalk, just define the sidewalk lane position and load in the structure typical section tab. Um, yeah, I don't, yeah, I don't, um, I guess I to include the sidewalk into rating. Um,
Well, I think that would depend. If you want the vehicle to drive on the sidewalk, then you would want to make it part of the travelway, right, Carolyn? But if it's just the pedestrian load, then it should not be included.
yeah. So as far as the question, should not define another vehicle and travelway for a sidewalk. Just define the sidewalk lane position and load in the structure typical section tab. Yeah, I don't think that you would define a separate vehicle or travelway, but this will allow you to position your vehicle loads. This will allow you to determine the position of the vehicle load, and whether or not it can be positioned on the sidewalk, but the sidewalk load will be computed just from the sidewalk.
Are you talking about pedestrian loads too? Or is it just the dead load from the concrete from the sidewalk? Or
Can you just speak here?
yeah.
Yeah, so my question is, if I have a deck, the deck has one vehicle lane and one pedestrian lane, and I want to, for example, the pedestrian load is 80 PSF. If I want to include this pedestrian load into my rating, I should not define another travel way. Just since
Correct.
my deck has a vehicle lane and a pedestrian lane, I want to include both lane into consideration for my rating. Yeah, I just
Right.
confused
Yeah, right.
whether I should define another travel way for the pedestrian load in order to include that load into the rating.
Yeah, no, I think, Carolyn, correct me if I'm wrong, the travel way, you don't need to define a pedestrian load for that.
Right, the
Pedest-
the travel way is only related to the vehicle position itself.
Okay. Yeah, since what I did before is I define two travel way, and I use a permit inventory vehicle which can allow you to define adjacent vehicle. So I define a sidewalk load as a land load, and I just assign the sidewalk load to the adjacent vehicle, but I don't know whether that's correct. Seems like
Oh, I see. I see what you mean. So okay, that's an interesting way of looking at it. So I mean, in terms of the analysis, I mean, it seems like that captures the loadings that you want to include. I guess the only thing just to mention is that um for the load rating itself, to get that rating factor, um that comes back to the rating equation with like capacity minus, dead load minus all of those other loads divided by live load, right? So if you're gonna model that pedestrian loading by creating an adjacent vehicle that's like a lane load, then that pedestrian loading sort of is included in the rating equation along with the live load, if that makes sense.
yeah.
So, I mean, from the standpoint of putting the loads the way that you did, I mean, I I guess it really just comes down to how you want to model it. But I guess that would just be the one thing to point out about that.
Okay. So I just wanna make sure if I just define the sidewalk, in this tab, will it be considered in the live load or just the dead load?
Well, okay, so I think if you have this pedestrian load, I think that it should, uh, I believe that this should, um, subtract out the pedestrian load. It's been quite a while since I've
What do you
looked
mean
at,
it will, what do you mean? You mean it subtracts out the pedestrian load from the capacity?
yeah, like, well, I mean, similar to how, okay. See,
It would
that's
add
what
it
I'm
in, it would add it in.
Well, I think
right.
I forget how we changed it, but I think it's treated similar to the adjacent live load because there's some like where you subtract it off of the capacity. You're talking
Yeah,
about the pedestrian load, so it's a numerator value for the rating rather than adding to the live load.
right. Yeah, that's what I would think
And this
that
was
it,
recently changed, wasn't it, Mark? It was like there was like a last few years there was
Yeah,
uh
that's why I'm not absolute. I mean, this is something that if you want to submit to support, we can give you an exact answer because there was
Okay.
some question over whether the that live load should be in the numerator or the denominator. And
and I'll tell you
it's the
it
same
was
with the adjacent load too.
and I think Mark,
yeah.
correct me if I'm wrong, but I think like the different states treated this differently, and
Yeah.
there was a big debate about it, like, and it was like maybe Cobb's should like take it up and make an official. I don't
Yeah.
know.
I thought this eventually got pushed back to the analysis tag, but I don't know that for sure.
There was actually discussion about this in the analysis tag pretty recently. And I think that they talked with the Safety and Evaluation Committee on Cobb's, and basically to ask them if they are planning on providing additional guidance about this soon. I think it's, from what I understand, they have been asked to provide specific guidance on that, but they have not looked at it yet, from what I understand. So exactly, like,
I talked to Mark about this. And I remember we talked about it.
but yeah, I guess you know, like Mark and Jeff mentioned, there are different states that want to handle this different ways. So if you have a specific question about how, or like a specific bridge, or you need more information about the, you know, a specific configuration, you can send that over to support and we can get you some info on that. But like we said, this is done differently for different states, different structures.
You're welcome. Okay. Sean, do you have anything final that you'd like to say?
Yeah, I don't have anything else to add, but just thanks everybody for coming, and I'll linger around a little bit longer in the Teams meeting if anyone has any follow-up questions. But yeah, I'll let you guys go. Thanks, everybody.
Thanks, guys.
Thank you.